Every day, somewhere on Earth, the ground trembles. Earthquakes are such a familiar part of our world that we hardly question them. But what about our closest neighbour in space, the Moon? Could that silent grey world also be shaking? During the Apollo missions, astronauts placed seismometers on the lunar surface. These instruments waited patiently, listening for the faintest rumbles. What they revealed surprised scientists. The Moon does have quakes, and they happen relatively often. Unlike Earth, where shifting tectonic plates drive earthquakes, most moonquakes can be traced to meteors striking its surface, but not all of them. A small percentage seem to come from deep within, hinting at something unexpected. The Moon is not completely still. It is shrinking slowly as it cools and contracts. Let's explore what this means and what scars it has left behind. The Apollo seismometers operated for years after the astronauts left. They detected thousands of moonquakes, some triggered by meteor impacts, others from tidal stresses, and a few whose origins were less clear. Think about it. Without ocean's atmosphere or moving plates, the Moon seems like a frozen world. Yet it still quakes. Some tremors were so strong that scientists compared them to magnitude 5 earthquakes on Earth. The question became, what could possibly cause them? The evidence pointed toward a planet-sized mystery. As the Moon gradually cools, its crust contracts and buckles. Just as a grape shrivels into a raisin, the Moon wrinkles as it loses heat. These subtle shifts create stress along its crust, which sometimes snaps in a quake. Let's see what these wrinkles look like and how they reshape the Moon's face. In the early solar system, nearly every world was a molten sphere of rock and metal. Intense impacts, radioactive decay, and gravitational compression kept them hot. Over billions of years, as bombardments eased and heat escaped, planets and moons cooled. Cooling inevitably leads to contraction. On the Moon, this process left behind remarkable geological features. Apollo photographs and more recent images from the Lunar Reconnaissance Orbiter reveal kilometre-long ridges scattered across the lunar surface. These features are called Lobate Scarps cliffs that can rise as high as 100 metres. Imagine walking across the barren lunar plains and suddenly confronting a steep wall of rock stretching for miles. These scarps are the visible wrinkles of a shrinking moon. Scientists believe they form through thrust faults cracks where the crust is pushed together until one block rides up over another. Some of the quakes Apollo detected may still be linked to these scarps, meaning the Moon's crust continues to adjust to this day. Far from a dead world, the Moon is still changing. The scarps are more than scars, they are time markers. Their appearance suggests they are geologically young, likely less than 100 million years old. How do we know? Some scarps cut straight across large craters. Those craters must have formed billions of years ago, long before the scarps. The fact that the scarps slice through them means the cliffs are much younger. This discovery is extraordinary. It tells us that the Moon's surface has not been frozen in time. Even in the recent past, and possibly even today, the crust continues to shift. These ridges have a distinctive shape, one side steep, the other shallow. If you've ever seen layers of rock folded and pushed upward on Earth, you'll recognize the pattern. The same forces that sculpt mountains here are at work in miniature on the Moon. When we look at these scarps, we're looking at proof that the Moon is not a static world. It is alive with slow, relentless change. There's another force at play beyond cooling Earth itself. Our planet's gravity constantly pulls on the Moon, creating tidal stresses. These forces may help determine where scarps appear. Imagine bending an old shell back and forth until cracks appear. That's essentially what Earth's gravity does to the Moon's crust. Scientists have mapped the scarps and found that many align with the direction of Earth's gravitational tug. Altogether, though the Moon hasn't shrunk by much, Since its formation over 4.5 billion years ago, it has contracted by only about 250 metres in radius. That may not sound like much, but geologically, it is significant. The shrinking has been enough to leave scars visible across its entire surface. If the moon's shrinking surprises you, consider Mercury. Early in its history, Mercury was a molten world. As it cooled, the contraction was far more dramatic than on the moon. Why? For one, Mercury is closer to the sun, which exerts immense tidal forces on the small planet. Combined with cooling, this caused Mercury's crust to buckle on a planetary scale. The result, Lobate scarps on Mercury that dwarf those on the moon. Some are 2 kilometres high and hundreds of kilometres long. From orbit, they look like giant claw marks raked across the planet's surface. Over time, Mercury shrank by up to 4 kilometres, more than 10 times the amount of the moon. Its surface bears witness to a violent geological past, one shaped by both its cooling interior and the sun's relentless pull. Compared to Mercury, the moon's contraction seems gentle, but both worlds remind us that even small rocky bodies continue to evolve long after their formation. So, is the moon shrinking? The answer is yes, but very slowly. Over billions of years, it has contracted by only a few hundred metres. The process is ongoing, but it won't make the moon vanish or crumble. Instead, what we see are the subtle signs of a living surface. Wrinkles, cliffs and moonquakes tell us that even our familiar companion is still dynamic. The moon may appear timeless when we gaze at it in the night sky, but beneath the surface, it is quietly evolving. This truth is a reminder. In the cosmos, nothing stays the same forever. Even worlds we think of as still and silent continue to change. The moon is shrinking, but its story is far from over. Its quakes and scarps show us that the universe is active, restless, and always in motion. Even the worlds closest to us still hold mysteries waiting to be uncovered. If you found this journey fascinating, let's keep exploring together. Subscribe to Cosmic Compass for more stories of planets, moons, and cosmic phenomena. Leave a comment. What amazes you most about the moon? Until next time, keep looking up, keep wondering, and remember, the universe is not silent. Every world has a story, and the moon's is still being written.